now that we have identified the appropriate intervals to graph each function, one way is to use a table. So we have the equation y equals -2, so that would be this one. And this happens when x is less than -3. So we are going to end up stopping our x values at -3, because that's where this pink value stops. It stops at -3. Anything after that is going to follow this rule. So that's where I'm going to stop this table at. And then I just have to fill in a couple values. So we'll say -2, or I'm sorry, we have to go decreasing. So -4, -5, and the rule is y equals -2. So at all of these values, y is going to be -2. And we could graph that. I'm going to graph them all here in a second. My middle interval is y equals 2x plus 4. So I'm going to say x and y, and I have to figure out what values to use. This says that -3 is going to be right where it starts. Okay, think about this yellow interval. -3, -2, -1, 0, 1, and 2 is where it stops based on what the function told us. So down here I'm going to put 2. And since this is linear, I know it's constant, so I'm not going to pick every single value. I'm going to pick numbers like -1 and then maybe 0. This will give me enough values so that I can graph the line. And when I say 2 times x plus 4, when x is -3, 2 times -3 is -6, plus 4 is -2. 2 times -1 is -2, plus 4 is 2. 2 times 0 is 0, plus 4, that'll be 4. 2 times 2 is 4, plus 4 is 8. So that's how I will graph that function. And now my last piecewise function is y equals 7 minus x. And this occurs on the interval from 3, which is right here, all the way to 6. Or I'm sorry, from 2 all the way to 6. So 2, 3, 4, 5, 6. And so I'm going to start my x values for this table at 2 and go, I'll probably just pick 4 and 6. You just want to make sure that you get enough. When I put in 7 minus x, 7 minus 2 is 5. 7 minus x, when x is 4, that's 7 minus 4 is 3. 7 minus 6 is 1. So now I have all these ordered pairs that I can graph over here. So for my pink interval, okay, y equals -2 until x is -3. And for this rule, we are including it because it's less than or equal to. So at the point -3, -2, I'm going to have a closed circle. And all my values from my table told me that it was -2. And use a ruler, and that is the first value. Okay, make sure that you have an arrow over there. Now for this one, I have the point -3, -2, which happens to coincide and intersect with this value. So since it's already colored in, I'm not really going to do anything with it. Then I have the point -1 and 2. I'm going to go ahead and put a point. Then I have the point 0, 4. Here's 0, 1, 2, 3, 4. And then I have the point 2, 8. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And then I connect these values. A ruler would be best. Okay, so I have that, and I'm going to stop right here. And I kind of messed up because here at 2, it's just less than. So when I connect this value, this should just be an open circle because it's not including this value, it's including this value. So when I'm at 2, 5, I have the point 1, 2, 1, 2, 3, 4, 5. This one's going to be a closed circle. Then I have 4, 3. 1, 2, 3, 4, 1, 2, 3. Then 6, 1. 1, 2, 3, 4, 5, 6, 1. And I stop at 6. So I just have a straight line. and it can equal 6, so that is correct that it's a closed circle. So this is my final graph, and you want to make sure that you check it, and it should pass the vertical line test at every point on this graph. And as long as it does, as long as it only intersects the graph at one point, you probably have the right answer.